We are now solving problem 23 from the MC10B from 2019. Points A, 6, 13, and B, 12, 11 lie on circle W in the plane. Suppose that the tangent lines to W at A and B intersect at a point on the x-axis. What is the area of W? So this is what the graph should look like. They intersect at a point on the x-axis, and there's a circle here. These two are tangent lines, but there's a point here that's x. Like, we set it to be x distance from the origin, so its coordinates are x, 0. Now, since both these two lines are tangent to this circle, we know that they are equal since they are tangent, and they also intersect at a common point there. So we want to find the area of this circle. Now, what we can do is we can formulate a system of equations by the Pythagorean theorem. So if we draw two lines down here and like a line down like that, we can use the Pythagorean theorem like this. We get x minus 6 squared plus 13 squared. Take the square root of that. This equals the square root of x minus 12 squared plus 11 squared. And solving for this, we get that x equals 5. So now we know the x-coordinate. This is 5 units away from the origin. So this is now 5, 0. So what we can do now is, since we have an x value, we can plug this value of x into here to actually find the hypotenuse. Since x was the x-coordinate and we were solving for the hypotenuse or these lengths, we plug this in. That's 1 plus 169, take the square root of that, is the square root of 170. As I mentioned earlier, these two are equal, so these are both the square root of 170. Now it's important to notice that from the circle's center, you can connect it to points A and points B. And you can also connect it to this point that intersects it on the x-axis to the center of the circle to give us two right triangles, because we know that if you draw a line tangent to a circle and put a radius on it, we know that it's going to be 90 degrees there. So we know that this is, so we can really just use Ptolemy's theorem here, which indicates that, we can indicate that 2 times the square root of 170 is equal to d times the square root of 40. So, therefore, we get that d is, after simplifying, we get that d is equal to r times the square root of 17. So we have this relationship. We can also we also want to solve for this Pythagorean triangle right here. So after solving for this hypotenuse, we get that r is equal to 85 over 8. So we have the radius of this, actually r squared, because when you solve it, it's in r squared units. Since this area of a circle is pi r squared, we just have to multiply 85 over 8 by pi to get our answer. That's our answer. We're done.